Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise where we're going to determine if an integral is improper. So far, all of the integrals that we had were proper. So let's try to understand what makes an integral improper. So two questions to ask yourselves. The limits of integration are both finite or not. So let's say like if you have somehow like infinity popping in one of the limits or minus infinity, that makes the integral improper. That needs a special treatment, which I'm going to explain. The second question is the integrand continuous on the interval of integration? If for some reason the function is not continuous on the interval of integration, that's again where you're going to call integral to be improper. Okay? So these three exercises are just to check if you have an improper or proper integrals to start with. I'm not going to show you the technique to tackle with improper integrals. That's going to be probably your next exercise. But let's just try to practice what makes an integral improper. All right, let's get started. All right, let's start with part A. I have a rational function 2x minus 5 divided by x squared minus 5x plus 6. The interval of integration is the interval 0, 1. So let's try to answer these questions here. In fact, two of them are essentially the same. So the first question is like the limits of integration are both finite. So these two questions are sort of like similar. At least one of the limits of integration is not finite. So these are similar questions. The answer of that is like the limits are 0 and 1. They're both finite. So I'm going to put a check mark here. I'm going to put a cross mark here. Okay. And in fact, second and third questions are similar as well. The integrand is continuous on the interval of integration, and the integrand is not continuous on the integral of integration. Let's see which one is happening here. So I have a rational function here, 2x minus 5 divided by x squared minus 5x plus 6. So both top and the bottom are continuous individually, but since this is a rational function, I have to check if there is any x that makes the bottom 0. Okay, so for that reason, I need to factor the bottom out. And I'm going to use my way, but you can also use your own way if you want to. So, and I explained this in earlier videos. If you like that way, please go with that. So I'm factoring this out as like x times x. I'm factoring this out as, in fact, together with the plus sign. Sign matters, okay? So negative 3 and negative 2. And when I look at the cross product of these and add them up, what I get here is negative 3x plus negative 2x, okay? And that adds up to the expression in the middle. Okay, so this tells me that the correct factorization for this is 2x minus 5, x minus 3, and x minus 2. Okay, this tells me that this function itself is not continuous, at both 3 and negative 2. Okay, because these numbers make the bottom 0, not the top, but the bottom 0. But fortunately, luckily, we have the interval of integration given as 0 and 1. So the interval 0, 1, right? So the interval of integration is 0, 1. And these numbers do not belong to the interval of integration. So therefore, the rational function is continuous. So I'm going to put a check mark here and a cross mark here. Okay, so what that means is this integral is not proper because, again, none of the limits involve infinity and the function is continuous within the interval of integration. So here the conclusion is that this is not improper. Okay, improper. Okay. We're checking if it is improper, right? So it's not improper. All right. Right. I think this is the end of the video. So please move on to the next video to see what I'm going to do for part B.